use numbers every day. Numbers are used in writing, in reading, and in counting. Sometimes we also see many different number systems show up. And sometimes we also see them used by computers to store data. Number systems and data storage in computers are interwoven with one another. But come to think of it, we see numbers every day, but what are they? Why do you need so many number systems? How do computers use those numbers to store its data? Let's get right into number system. Numbers are symbols that represent a value that can be used to count, label, and measure. It can also be used in arithmetic operations such as addition and multiplication. The usual number system that we use on a day-to-day basis is called the decimal system, or base 10, which is a number system that is represented by 10 different symbols. Next, we shall discuss binary numbers. Binary numbers are much different than normal decimal numbers because a binary number is a number expressed in the binary numeral system, which is a base 2 system. It only uses two symbols, 0 and 1, which are also referred to as binary digits or bits. A bit is the smallest unit of data in computing. A collection of bits represents data. For example, 8 bits represent a byte, which can technically represent 256 different values, which is from 0 to 255. Next, I'll be explaining about converting between these two number systems. Converting a decimal number to binary is done by dividing the decimal number by 2 and recording the remainder until the quotient is 0. Here's an example so that it could be more understandable. Let's say we want to convert the number 22 into binary. First, we should divide 22 by 2, which gives us 11 with no remainder. Then we divide again, giving us 5 and a remainder of 1. We do this again and again and again until the quotient is 0, and the result is the binary number 10110. Next, there is the hexadecimal system. In contrast to decimal, the hexadecimal system makes use of 16 symbols instead of 10. After the number 9, the number system turns to the letters A, B, C, D, E, F rather than more numerals. The hexadecimal system will be useful later when we look at how data storage works. However, you should think of a hexadecimal number as a compressed binary number. Hexadecimal numbers require a total of 2 to the power of 4 numbers. Therefore, each one can be represented as a series of 4 binary values. And sure, it still functions in the same way that binary numbers do on computers. The hexadecimal system was created for a simple reason, that is, it is easier for humans to understand and convert to binary. But why do we need to know all these binary things? Why can't we simply utilize the decimal system that we're all accustomed to store data? All you need to understand is that the computer element that stores data functions similarly to a collection of really little light bulbs. And since those light bulbs only have two states, on and off, it's way easier to represent them using zeros and ones rather than 0 to 10. That's why people use the binary system to store computer data. Now, how exactly can we use these zeros and ones to store data other than decimal numbers? We can represent many different types of data in a language that computers can understand. For example, text can be encoded with ASCII, which uses 7 bits to represent a character, or UTF-16, which uses 16 bits, or 4 hexadecimal numbers to represent a character. Right now, people usually use UTF-16 because it can encode basically every language in the world. Next, images can be encoded by storing the red, green, and blue value of its pixels. Each one of those values are represented with a byte or 8 bits. This can be written in RGB format, which uses 3 decimal numbers ranging from 0 to 255, or hex code, which uses 6 hexadecimal numbers. Audio, on the other hand, can be represented by slicing up the piece of audio, sampling the small piece, volume, and pitch, and encode those values into bits. And finally, videos. Videos are quite straightforward since they're just a series of images played continuously one after another with an audio file playing in the background. To summarize, in this video we have learned how number systems such as decimal, binary, and hexadecimal work, and how they can be used to store computer data such as text, images, audio, and videos. Thank you all for watching the first part of this video. Hopefully I'll be able to see you again in the next video.